as we could see here, when the underlying asset price goes from 40 to 100, the call price increases and the put price decreases. This is very straightforward because of the definition. Okay, please next slide. Then we talk about the delta. We should mention that two things about delta. First, the delta of call option is always positive, and the delta of put option is always negative. This goes in accordance with the previous slides, and we should notice that the absolute value of call delta actually increases, while the absolute value of delta of put option decreases along time. Please go to previous. Yes. As we could see here, when let's say call option, for example, when the call option is deep out of the money, and when the underlying or we could say stock price increases and the call option increases a little. That's why first the delta of call option is always positive, and the second the delta here of call option is very slow. It's very low and increase very slow. However, when the call option is around at the money here, because with the strike price is 6.8, and then the delta increase fast, and then when the call option is deep in the money here, the delta is increase very fast and goes to almost 0.1. Okay, next. Then we go to the gamma here. Gamma. We should notice that the gamma is always positive because the convexity of put and call option. The second thing we should notice that is that around the strike price 6.8, the gamma is the highest. That is because what the gamma mean? Please go previous. As we could see here, the change of delta is the highest around here. It's around the 6.8 strike price. That's why gamma is the highest around the strike price 6.8. Okay, go next. Here. Now let's go to the theta. Theta is the rate of change of option with respect to time and time to maturity. As the time goes on, time to maturity decreases, and both the theta of call option and put option should be negative. But one problem we should think about it. Why here? Why is it positive? Could somebody answer my question? I will give you extra question. Sorry, I don't have the authority. Okay, go next. This is a very interesting. I want to explain this because let's say put option. The theta put option, especially for the put option that is deep out of the money here. We always say that the value of option has two values: intrinsic value and plus time value. Okay, let's see here. The put option is deep out of the money here. So as time went on, the time value will decrease. There's no doubt the time value will decrease, right? But intrinsic value, it will be constant. No, because actually, what we mean by intrinsic value, because both call option and put option price are the discounted value of intrinsic value. Therefore, it could multiply discount factor here. As time to maturity decrease, the discount factor actually increase a little bit. But when the intrinsic value is very big, so when the impact of decrease of the time to maturity will increase the discounted intrinsic value bigger than the time value decrease. Therefore, the put option price will increase. That is why partial P and the partial T is bigger than 0 when the underlying asset price is much smaller than the strike price. This is why for put option, when it is deep out of the money, the theta is positive. And another thing we should notice that around strike price 68, the theta is lowest. That is very straightforward because we know that option has the highest time value when option is at the money. So when the time change, when the strike price change, when underlying asset, when the time change, the theta should be the lowest because the time value will decrease. Okay, next. Let's go to the Vega. Here, Vega is the rate of change of option price with respect to the volatility of underlying asset. Here, again, we should notice that the theta is biggest here when the option is at the money, because when the option is at the money, the volatility matters very much. Let's say put option that it is out of money, so it's here, the strike price is here. However, when the volatility changes a little bit, the out of money put is more likely to change to the in the money put. And for call option, for example, the underlying asset is here, the call option is out of money, but when the volatility changes a little bit, it's more likely that the call option will jump into the in the money call option. So the Vega is highest when underlying asset price is around the strike price here. It's 68. Okay, next. Let's go to the rho. Rho is the rate of change of option with respect to interest rate. It's the risk-free interest rate. We should see here. First, the call rho is always positive, and the put rho is always negative. Another thing is that the absolute value of call rho goes bigger when the underlying asset price goes bigger, and when the underlying asset price goes bigger, however, the absolute value of put rho goes to 0. This is very complicated because rho is measured by two things. Okay, I put it right here. When the risk-free rate increases a little bit, let's say a call is equal to the discounted expected value of ST minus K and 0, positive. And put option value is discounted expected value of payoff at time big T. As we could see here, when the risk-free rate increases a little bit, risk decrease. And the expected value of payoff at the end of T, well, it will increase. Because when the risk-free rate increases, because please notice that we are talking about non-dividend underlying asset. Let's say it's a stock. The stock price will increase because the investor will require the higher interest from stock because it's non-dividend. All the profit will increase in the stock price. It will increase very much, and the discounted factor value will decrease. in his book that this leads to the call option will increase. But for put option, it's not complicated because this will decrease, this will also decrease. Of course, the put option will decrease. That explains why the graph is like this one. Okay, thank you. These are our projects. Do you have any questions?
Applause.